Okay, so what did I do? I constructed a URI exactly according to what the documentation said. I didn't have to say get because by default curl will always use get unless you tell it otherwise. That's covered in the homework. So my path begins with api.themoviedb.org/3, just like they said. That's always the base URI. Then /search/movie, that names the operation, right? That's the function I want to call. And after the question mark is the required parameters. Remember that we said one parameter that's required should be named query, and the value is whatever string you're searching for. I search for Coco, which I dearly love as a movie. And the other required parameter is your personal API key. By the way, I'm going to make all this available online, but if you use it, please don't use my API key. I don't want them to hate me. Sign up for your own API key. Just go to their site, and there's a place you can click, and you set up an account, and it takes like a minute. So my API key is the one that appears in all the live examples. So if you're watching this in Webland, please don't use my API key, or they'll hate me. So those are the only arguments that I passed. And because that JSON stuff was kind of crappy to read, we can do this instead. Let me grab this entire URL. And I'm going to instead paste it into my browser. So remember, I was at Nikki? Was it Nikki? Nikki asked before, can you just curl to any website and can it like not tell the difference if it's a browser? And I said, yeah, pretty much. That's what you can do. So I'm going to just get the exact same URL, but instead of using the curl command line tool, I'll have my browser do the work. Why am I doing that? Because I have a Chrome plugin called JSON View, which actually indents the JSON and makes it nice to read. So now we can actually see in a little bit of detail what came back. So can you, yeah, you can see my cursor, right? OK, so welcome to JSON by example. Here's my one slide about JSON, and then we'll actually show you what's going on in my browser. JSON is so called because it is a ASCII notation for transmitting data around that happens to resemble the syntax that JavaScript uses for representing that same data, hence JavaScript object notation. So what does it look like? A JSON object, that's the main unit of stuff in JSON, is just called an object, right? Super creative. It is an unordered hash. And as we all know, a hash is just keys and values whose order is irrelevant. It's enclosed in braces syntactically. Hash keys have to be strings. The hash values can be a string, a number, an array if you put it in square brackets, or another hash if you put it in nested brackets. So you can build up pretty complicated data structures with this, as long as everything in the data structure can be represented as one of those four kinds of stuff. Key value pairs are separated by commas. White space doesn't matter. So here's a very, very simplified but legal piece of JSON. I have a single object, right? Curly brace, curly brace. Within that object, I have a key called title. Its value is Coco. I have a key called rating. Its value is G. I have a key called genres, whose value is an array. And it's an array of hashes. Each hash looks like it is something encoding a particular movie genre. So here's the animation genre, whose ID internally in the movie database appears to be 16. Here's the family movies genre, whose ID internally looks like it's this long number. And finally, there's a vote average key, and its value is 8.1. Presumably, that's the average of all MovieDB users' votes of how good that movie is. OK, so this is a super simple JSON object. If we now go back to my web browser, and we can look at the one that was actually produced in response to my real-life query, it's basically the same deal. It's just a more complicated object with more fields. So it's a single object, right? There's my opening brace. Should I make this bigger? Is that a little easier to read? There's my opening brace, and if I scroll hella down, yes, there's my closing brace. Woo! So it's one object. Most JSON responses are structured so that you get a single object back. What's in the object? Well, let's see. I have a slot called page with a value of 1. Total results. That is, presumably, that's the total number of things that matched my search string Coco. So I was just interested in the one movie called Coco, and you'll notice that it happens to be the first result returned. So yay, the movie database for doing the right thing. But there's 152 other movies that have the substring Coco somewhere in their title, apparently, which I don't care about. And as you might imagine, if the total results is 153, then this thing called results which is an array, is probably an array of how many elements? Not a trick question, 153, right? And I'm not going to read every single array element, but you get the idea that each array element is another hash representing the specific data about a particular movie that matched, right? So this is how we read API documentation. If we go back to the page that describes this, we can see that indeed, what response should I expect? Well, I'm going to get a JSON object, and inside that object, I can expect to find a page count, a results array, which is an array of other objects, and then inside it's describing what the fields of each element in that array are going to look like, right? So basically, this is, where did we start this? We said, how do you name the function to be called? Well, now we know. You look at the API documentation, you find what the base URI, the name of the operation. How do you say which arguments are necessary, and how do you pass those arguments? Again, you look at the API docs, and you can see that in this case, API key and query are required. So we had to stuff those into the URI. We could have, but in this case we did not, we could have specified a language argument that would display translated data. So if I wanted the results to come back in a language other than English, and it says that if I don't specify it, the default is English in the US. We could have, but we did not, specify include adult, a salacious argument that says whether pornography should also be included in the results. The default answer, in case you're wondering, is it does not include pornography in the results unless you specifically ask for it. We did not ask for it, so if there are dirty movies called Coco, they're not going to be in our list of results returned in our browser. And then we said, well, what if there's an error? That's the one thing we haven't covered. We know how we get data back. It's that big JSON data structure that's described down here. But what if something goes wrong? Well, let's make something go wrong. What's an easy thing that I could make go wrong here? Somebody suggest a way to break this query so that it doesn't work anymore. Yeah, I could. In fact, let's just leave the key out. I'll just get rid of it. And now I do the whole request again, and so important, okay? HTTP is a request reply protocol. Did I get an HTTP reply? I did. In fact, what is the probable HTTP status code of the reply? For something, right? And that's because you were paying attention, you remembered somehow that for XX means I understand what you want to do, but I'm going to have to turn you down on this one. Okay? And in this case, I still get a JSON object, by the way. So if you're wondering, well, if you're always going to get a JSON object back, how do you know if the object you got is the answer to your query or if the object you got is something else? Well, if your query had gone well, you would get an HTTP response code of 200. And then you would know that the JSON object is whatever the data is that you asked for. In this case, the HTTP response was something else. And in fact, we're going to curl it in a moment to prove that to you. So you still get a JSON object, but now it has something else in it. It's got, in particular, an explanation of what went wrong, right? The status code is some internal status code that the MovieDB uses. But the status message is much more useful, which is, this is the reason that I'm not giving you a result. And if we now try this exact same thing, so we're going to curl this puppy. Oops, that needs to be a quote. Oh, and let's do curl-v so that we can see the headers. There we go, okay? Remember how the left pointing arrow is showing what the server headers coming back? The server, the first line of the server is 401 unauthorized, which makes sense, right? We didn't include an API key, and without that, it can't identify that we're somebody who is previously registered to be authorized to use the service. As you go off into the wide world to experiment with APIs on your own, a few different choices of how to do it. We've been doing it manually. I call this the hard way. So you've seen me using the curl command line tool. If you have Linux or Mac OS, it is standard. You can also download it for Windows. And then in my browser, I installed the JSON View browser extension that makes the JSON look all nice and indented. But by the way, JSON as a data format does not care about white space or indentation. That is for us humans. So that's why the JSON View browser extension is so nice. You can like collapse and expand little pieces of it and stuff like that. You can also, in many cases, the website that has the API docs will have an API Explorer built right into it. Let me show you. If I go back to my here we go. So here is, for example, the example page for the get movie/movie ID, details about a movie. And notice this tab over here, which says try it out. So I'm logged in, so it actually knows my API key already. But normally, when you logged into the site, this would be blank. And you would actually have to paste in what your API key is. It's telling me which parameters are required and which ones are optional. I think I remember that when we did the movie search, the ID of 3 was the one for Coco, so I'm going to put that in. So basically, now it's showing me kind of a preview. You can see right here, right? This is the preview. I'll make this bigger so you can actually see it. This is a preview of what the entire route is going to look like, right? So we've got the standard base URI prefix, the name of the method, which is just /movie. It's scrolled off the top. The required parameter movie ID, which is part of the route. And then after the question mark, the only other required parameter here is the API key, which I pasted in. This language parameter happens to be optional, but if I just blank it out here, you can see that it updates the preview of the URI. So I recommend if you spend a little time playing with one of these sites, you start to sort of get a very instinctive feel for how the API description, right, the name of the function, the parameters, is going to look when it gets all mungled together into a URI. And then it lets you actually try the request. And you get sort of the pretty decently formatted JSON view. You can also do this JSON Explorer thing, which lets you do the flippy triangles to expand, so you don't have to read everything at once. So this is sort of a nicer way to do the experimentation. Most self-respecting sites that have an API have something like this that's basically embedded in their documentation. So as you're reading the documentation, you can actually try things out live on the site. And although we are probably not going to have time in the course to cover it, it may interest some of you to know that there is a standard now called OpenAPI, which is a way that you describe your API in JSON. So it's a little meta, but stick with me. You're describing like which calls are allowed in your API, which parameters are optional and required, whether an authentication key is required, all that stuff. And there are frameworks that will take that description and generate your documentation along with the try it things and some basic tests that you can put into your app. It is super, super sweet. We probably won't get time to do that, but if you're interested in OpenAPI, check out Postman, which is a free app that lets you experiment with and design APIs. Like all tools, it has a high learning curve. So unless you sort of like want to eat, sleep, and breathe APIs, I wouldn't spend a lot of time on Postman. I think the tools that we've been using are enough to sort of get the flavor of what you're going to need for this class, along with the API Explorer sites. But for those of you who are absolutely obsessed with going further, Postman is a good place to start. CRUD is the usual acronym, but I prefer CRUDI because in reality, there's one operation that always gets left behind. So the 4 operations on a basic resource are: it can be created because it didn't exist before. It can be read because it exists and you would like to have a version of it. It can be updated, which means it exists but you want to modify something about it. Or it can be destroyed. And in the case of a collection of resources, you can also ask for an enumeration, right? A list of all of them. So with the movie database, we asked for a list of movies filtered by some criterion. In our case, we used the substring of the movie title. And once we had a list of matches, we were then able to ask for a read specific details about one particular element of that collection. So here's kind of my simplified schema. Here's a way that you might represent an operation that says get/movies, which is my shorthand for saying, give me the resource in question here is the collection of all movies. Now, in real life, you probably don't want the entire collection. You could imagine optional arguments like we had before that would narrow the search in some way. But for the sake of argument, get it? For the sake of argument, we could say the result is going to be something that is probably a single JSON object, and the single key is something like movies, or maybe it could be results or something like that, with an array valued value that in turn gives little hashes of all of the movies in our database. So here's like the world's simplest version of the movie database. If we were doing a real simple version for ourselves to illustrate how these different routes would work. So if that's an example of a get, what are some other possible routes for manipulating resources associated with a movie? Okay, well that was the index, right? Give me a list of all movies, and in real life we'd probably provide for some optional arguments to filter the results down. So what about read? Well, if a movie exists, we could say something like get movies/253. That might be a nice RESTful route for saying I would like a representation of the movie whose ID is 253, assuming that that ID exists. We could return a JSON representation if the call came through our API portal. We could return an HTML page with nicely formatted information if the request came from a web browser. And yes, you can tell the difference. So one thing that frameworks like Rails let you do is you can actually have the same code do the processing of the request and only switch at the end depending on whether the user was asking from a web browser, so you return something with a UI, or the user was doing a call through an API portal directly, in which case they probably want JSON. So there's a lot of automation around things like that. A thing to observe from this kind of route is that usually for read, when you're trying to get a specific resource, the argument that names the primary resource is often part of the URI path. That's not a rule, it's not a law, but it is convention, right? It is one way of saying not only is the argument required, right? Because if I'm saying get information about a movie, it makes no sense unless I specify which one it is. But in addition to that, it makes it possible to crystallize this question about can you tell from the basic route what is the primary resource affected? Yeah, you can. It's movie ID 253, right? And a reasonable assumption is because it's a get, which is supposed to not cause any side effects, that this is a way of asking for specific details. What about index? We already saw get/movies. Here's a version of how it might look if our API supported an optional argument called name, which could be used to filter down the results to only match things that had these terms in them. In this case, the primary resource is the movie catalog itself, right? So we're still doing a get because we want to read the resource. What's the resource? /movies with no other qualifiers. That's probably the collection, right? We haven't identified a specific one. But some optional additional arguments will let us sort of customize the view that we want to get. We don't want every single thing in the catalog. We want to filter it down according to whether the name matches these terms. And we could provide other ways to match it down too. Right? So again, the three RESTful questions. What is the resource? What is the operation being done on it? And is any other data necessary or could be specified that could affect that operation? What about updating? We've already sort of said that if an action has a side effect, you should not use a get route to name that action. That's bad practice. That, by the way, has to do with the early days of the web when people realized that, boy, some web pages are really, really popular, and it would be great if there were caches all over the place. If you've taken 152 or a 61C, you know about caches. It's a place where you can have an additional copy of stuff, or many additional copies, so that larger demand can be served. But unfortunately, the way that a cache would work is the cache would have to ask the main server for a copy of the page so that it could have a stored version. That version could be redistributed. What a bummer if using get to get a copy of a stored page has a side effect, like buying something or making a change. So from the earliest days of the web, it's kind of been a mantra that get requests should never cause a state change. The convention that has emerged for RESTful APIs is that post is for creating a new resource, either put or patch is for modifying an existing resource in place, and delete is for, guess what? Deleting a resource. Now, we're going to return to the question later of most web browsers, in fact, all that I know of, only ever do get and post requests in response to user actions. So if that's true, how could your application ever see a put or patch or delete request if it's originating from a web browser? So we'll push that on the stack and come back to it. So an example would be something like if we do post/movie, and in the body of the request, we would include some representation of what we want to create. If we wanted to modify an existing movie, we would do something like patch/movies, and now we have an ID, right? Because update implies the thing exists already. We just want to make a change to it. And depending on the specific API definition, depending on what the documentation says to do, sometimes you're supposed to provide an entire copy of the thing and just, with changing whichever fields you want. Other APIs allow you to just provide the fields that you want to change, and any fields that you don't specify are assumed that they should be left as they are. One sort of discussion in the web community is that, in general, if your API requires you to send the whole thing to modify, you should use put. But if your API allows you to only send the pieces you want to modify, then you should use patch. It's not clear that that debate is going anywhere. The result is sort of the worst of all worlds, which is Rails 5 allows you to use either one, which probably satisfies nobody. Yeah?
Is there some reason in that example why they had to put the ID as 250? Because obviously that didn't change, right? Or since it was called.
Oh, good point. So in this case, why is it that I have to specify the ID as part of the route, but I also included it as part of the body? Probably because I'm stupid. I probably just missed that. And in fact, if I had included it, whether the API calls that an error or whether they would cross-check it to make sure it matches the route, would depend on reading the docs. The answer for my slide is I screwed up. I'll fix the slide before I post them. OK. And to address a question that was asked earlier, when you're doing an update or a create, sometimes the response is just the headers. So like, OK, it worked, or no, it didn't work. Other times, the response actually includes some representation, probably in JSON, of the thing that was created or updated and what it looks like after the operation was successful. Sir?
Are there fields that you're not allowed to change? For example, you couldn't create an ID with 53, right?
Yeah, so the question was, are there some fields that you are not allowed to change? Guess what I'm going to say? You should read the docs. Every API is different, but in general, it is the case that there are some fields you're not allowed to change. For example, in a lot of APIs where you can get information about yourself as a user, one of the properties you can get about yourself is like your level of privilege. Are you an admin user or like a plain old person? And usually you can't just like change that for good reasons, right? And whether such changes are silently ignored or generate an error, read the docs. There's a lot of reading the docs. Have you guys noticed? It's a good thing to do. OK, what about operations other than these basic ones, which is create, read, update, delete, index, which is list the collection? What about, going back to the movie database as our example, what about this operation? Suppose we want to define a route for add a movie to my watch list. Anybody want to suggest, take a crack at this? Where does that fit into our scheme of the world with CRUDI? Somebody in the back. The front is overrepresented. I think tomorrow what I'm going to do is I'm going to lecture like from here. This is a totally different feel, isn't it? Oh, thank you. Yeah.
I was going to say, maybe you do like multiple operations where you like first get to see if you have that movie, and then if you have it, then you like post it to a new database, which would be your watch list.
OK, so I have one proposal, which is we could do this, but we could do it as a sequence of multiple operations, having to do with checking whether something is in a list, and if not, we do another one to add it to the list. Somebody else. I'm going to stay up here until I get more answers from you guys, so get used to it. The sound wall is preventing me from hearing you. Please speak more loudly. Do I have to turn back to the front of the room? Are you guys willing to suffer this? Yes, please.
If you have one list of user records, presumably, so you update a user to have their watch list included.
Now we're heading in the right direction. So if there's a notion of a watch list and a user record, this is fun. I feel like Geraldo Rivera or something. That was the real answer, and it was kind of a trick question. So thank you for getting the answer that I'm trying to drive people to, which is if it seems awkward to express an operation in terms of the resources you have, maybe you don't have all the right resources. Maybe there is another resource type waiting to be defined, and it has some relationship to the existing resources. But if you had that other resource, then the answer to the question would have been obvious. So in particular, in this case, if there was a resource that represented a user's watch list, now the answer is obvious, right? If we had that resource, like, oh, OK, we're just updating that resource because we're going to add one more thing to it, the ID of some movie. So what you'll find is that this will sometimes result in a simpler design, because even though you've had to add a resource type, that resource type just has the basic operations on it, right? So it kind of regularizes the design of your app. So let's walk through that. To sum up where we are with RESTful APIs, the thinking is everything is a resource. So the most basic things you can do to a resource are you can create it, you can get it back, you can update it, you can delete it, and you can ask for an index or a list, maybe filtered, of all the instances of it. And often you'll find that if you're trying to express an operation and it's not clear how you get it into that narrow mold, maybe there's a resource that you have not thought about defining. A very popular example we used about this in a previous offering of the class is if you were making a social networking kind of site, and you wanted to express, clearly a user is a type of resource. What if you wanted to express the idea that two users are friends? How would that fit into a CRUD scheme? By the way, anybody want to take a crack at that question? If you were designing a social network that wasn't about to tear apart the fabric of democracy, how would you represent the idea that two users have a friendship relationship of some kind? What might you do?
Make an attribute like a list that you can add friends to it for each.
OK, so one possibility is you could have a friends list, and each friend could have or each person could have a list, and then if someone is added to that list, they become your friend. However, one drawback of that is that suppose you have your list, and although I don't really deserve it, I'm on your list. It is certainly easy to ask, what's your name?
Tina?
It's certainly easy to ask, is Armando Tina's friend? And so you just go to Tina's list and you see if I'm on it. But if you want to ask whether Tina is Armando's friend, now I also have to have a list where she's on it. And if those lists get out of sync, then badness could happen. So that is one choice, but is there maybe a way to avoid that? What else might one do? I want to favor the back just a little bit. Don't make me go back there again. OK, fine, I'll go back there again. I know, get used to this, kids. All right, come on, someone. Yes?
You could basically have like a giant set of all friend pairs, maybe?
Of all?
Like friend pairs.
A set of friend pairs. So let me translate that into RESTful speak. We will define the relationship of being friends as a kind of resource. So now a user is a resource, but a friendship is also a resource. And a friendship resource basically is just the two user IDs of the people who are friends. And by the way, now that the friendship resource is its own thing, you can also capture other information there, like when did they become friends? When is the last time they had some sort of interaction? And so forth and so on. OK, so again, when it's not clear how to express something with the resources you have, ask about, is there a representation of the actual thing, a new resource waiting to be defined? And if you define that resource, then it would be as simple as it's one of the CRUD operations, pretty much. OK, so to summarize, RESTful operations, what does it do? It identifies the resource, what is to be done, any other data, and in the best of cases, the URIs themselves, that part of the route, might even give you a clue as to the relationships among different kinds of resources. So as a developer, it sort of lessens your cognitive load. You say, OK, I'm not sure how the whole API works, but I know that whatever B is a thing that sort of belongs to an A. So maybe A is a user and B is a list of friends. A is a watch list and B is a list of, or A is a user and B is a watch list. But the relationships are brought out right in the URIs. Now, it's not always this simple, but it's a good starting point. And finally, we've seen that a resource can have different representations. If you're interacting with the movie database through a web browser, what you're getting back is nice HTML pages. If you're interacting with it through the API portal, you're getting data structures usually as JSON. And that's where the representational part of REST comes from. Right? It's representational state transfer. The thing you're getting back when you get that blob of JSON, that is not the resource. The resource is stored at the server in a format that you are ignorant of and must remain ignorant of. Otherwise, you'd be able to reach into that database. Right? Part of the mantra of service-oriented architecture is everything that you do has to be available through an externalized API. So all you can see is the representation of the resource, the one that you asked for. How it's stored internally, you have no idea, and you should never want to know. And finally, why is REST a thing? Because it's simple. It's easy to understand. We've covered it in like less than 2 lectures. It matches the engineering constraints of the web. So the idea that gets shouldn't cause side effects, that URIs have a syntax that you can sort of hijack to make these relationships clear, it was nicely matched to what the web was already doing well. Right? And it didn't require developers to sort of learn a lot of baggage to do really simple things like get me a list of movies matching Coco. That's REST in one lecture. So if you haven't been paying attention up till now, this is the kind of slide that is designed to cue you that it would be a great time to pay attention. The most important idea, in my opinion, about this material is that when you're thinking about designing what we would call a web app, a thing that a human being would interact with through a browser, think of it as a service whose resources and operations are RESTful. Right? So as we've seen, JSON and less these days XML is a way that programmatic results are returned. HTML is a way to return stuff that can be rendered in the browser. But what you're thinking about when you're designing an app is what are the resources that your app manipulates? And what are the relationships among those resources and what operations are allowed to be done? That is what designing an app really is. And what you'll find is that besides the fact that it leads to a very clean design, a lot of modern frameworks, especially Rails, save you a lot of time if you think in this way. If you really channel your thinking towards, all right, the customer has asked for this new feature. The customer thinks in terms of behaviors. I want the app, when I do this, I want to get back a page that looks like this. Your job is to turn that into, OK, what resources do I have to have a representation for in my system? And what operations on those resources would support the behavior that the customer says that they want to see? If you can get your thinking into that mode, your app becomes easier to build with a modern framework. It becomes easier to test. It becomes easier to understand. And it lends itself to having a programmatic API, like the movie database that we've been using, that you get almost for free alongside developing the app by itself.